All right, picking back up with number 32, determine algebraically whether the graph is symmetric with respect to the x-axis, the y-axis, and the origin. Let's just graph this and not do the algebraic part because we didn't really do the algebraic part in class too much. So if we get graph 5x squared minus 5, y equals, oops, let me get off the pen. Just go to the pointer. Y equals 5x squared minus 5, clear that, 5x squared minus 5, and I graph it. And what we want to figure out is if it's symmetric to the y-axis or the x-axis and the origin, and this appears to be symmetric to the y-axis. So y-axis only, not the x-axis, not the origin. It doesn't rotate at all. So this would be the y-axis. So I'm going to answer B. All right, 33, if I graph this, y equals the absolute value of 20x. I need to be back on a pointer. Y equals, I'm going to go to y equals. I'm going to clear that out. I'm going to type absolute value, which is math. You go over to number. Y equals the absolute value of 20x. I'm going to graph that. And it again, I could make my window bigger, but again, it's only the y-axis that is symmetric to. All right, 34. What if I take the point -1, 4 and make it symmetric with respect to the origin? So -1, 4 is here. When you make something symmetric with the origin, you rotate it all the way around the origin. And all that does is it changes your sign. So it would be +1, -4 is what it would look like if it was symmetric to the origin. All right, number 35. What if I have the point 7, 2 and I reflect it across the x-axis? So if you're at 7, 2, it's approximately over here. Over the x-axis would put it at 7, -2, just the same point over the x-axis. So that answer would be A. If I want to know if it's even or odd or neither, even is going to be if it's symmetric to the y-axis. Odd is going to be if it's symmetric to the origin, and anything else is neither. So this one's not even, but it is odd. This part, if you turn your paper exactly upside down, it will look exactly the same because this goes to this, and then this part rotates around to this part. This is an odd function. Typically your cubic functions, or this is probably to like the 5th power, this could be or this could be even a cubic as well, but these are the odd types of functions. This one's split with the y-axis, so that is going to be even. It looks like a parabola. It looks like an x squared. X squared is an even number, right? The 2 is an even number, so we're talking an even function. This would be neither because the y-axis does not split it in half. It doesn't go through the origin, so it's not odd. So that's going to be a neither one. All right, number 39. How can the graph of f of x equals negative square root of x plus 4 be obtained from the graph of y equals the square root of x? Okay, if I have y equals the square root of x, and then I add a negative in front of it, that reflects it across the x-axis. If the negative is underneath here, it'd be across the y-axis, but it's not. It's in the front. So that's going to reflect it across the x-axis. And then a plus 4 underneath a radical is going to move it left 4. If it was outside the radical, if there was a plus 4, that would move it up or down. But underneath or inside the grouping symbol is the left or right, and it's always the opposite of the number. So a plus 4 moves it left 4. So I want to go 4 units to the left and across the x-axis. You could also graph these. If you came to your calculator, you could, in y equals, you could graph in y1, do the square root of x, and in y2, do the negative square root of x plus 4, and then watch them graph. Okay, here's my first one. All right, that's the square root of x. And then my second one is flipped upside down across the x-axis, and it's shifted to the left 4. So you can also graph them and take a look at it. You just need to put the original in there first and watch them graph and see what happens. All right, so back, oh, I didn't mean to do that. Let me pause and get that. All right, number 40, how can we obtain this graph, x minus 2 squared minus 7, if we start with this graph, y equals x squared? Well, the minus 2 inside is going to move it 2 units right, and the minus 7 outside is going to move it 7 units down. So that would be down 7, and 2 units right would be b. Let's look at that on a graph as well. I'm going to start with y equals x squared. So that's y equals x squared, and I'm going to move to y equals x minus 2 squared minus 7, I think is what it was. Let me go back over here and look. Do be careful because your tendency is to put this one in first, but it says how can this graph be obtained from the graph of y equals x squared? So that means I had to start with this to obtain this one. So this is my original one, this is my new one. So y equals x squared, x minus 2 squared minus 7. If I graph it, here's my original, and here is my new one coming in red, and it will be if you'll look, the vertex moves over 2 and then it moves down 7. So this was my center point, and it moved over 2 to the right and down 7, which was my answer. 2 units, well, that's hard to read, right? 2 units right and 7 units down. Number 41. All right, how do we obtain this graph? Again, now this time, the negative, is inside. So that's going to be the y-axis that we're flipping it over, not the x-axis like was in the previous. That's the y-axis. This is going to be 9 down. And this out here, a 0.4, when the number out in front, that's always a vertical. And if the number in front is larger than 1, it's a vertical stretch. If it's smaller than 1, like a fraction amount, it's a vertical shrink. So this is going to be reflected across the y-axis. So now we're down to it not being b, it not being c. Shrinking it vertically by factor of 0.4, so that's both. And then vertically 9 units, it's going to be downward, not upward. So that's going to be a. We can graph those. It'd be y equals the absolute value of x. All right, so I have y equals the absolute value of x. Let me go over here and change it to this. Y equals the absolute value of x. Go to clear that out. Go to math, go over to number, and it's the absolute value of x. And then here, it's going to be 0.4 times the absolute value of negative x, and then it's minus 9. Minus 9. So let's take a look at these. Graph it. Here's my first one. So then what happens? Well, it is taking this down 9, right? But it's also, and it's hard to tell that it's been reflected across the y-axis, but it went from left. It definitely wasn't across the x-axis, so hopefully you can notice that. And there's a negative, so you know it had to be a flip. And this is vertically shrunk. It is not rising at the same rate. So that's where that vertical shrink comes in. All right, let's go to the next thing and see if we can do that. Okay, take a look at, okay, if I take the graph of f of x and I add 1 to it, so that's not inside the parentheses, that's an add 1 on the end, so that moves it up 1. That's an up 1. So if I am at 614 originally, 614 somewhere here, and I move that point up 1, where would I be? I would be at 615. All right, take a look at this one. If I have a graph, now there's a minus 1 inside the parentheses, which moves it right 1. So if I'm at 414, 414, and I move it right 1, that would put me at 514. So that would be that. The number outside is your up and down, and the number inside is your left and right. And the inside is always opposite what you would expect it to be. I'm going to pause this, and I'll finish the last 7 in the last video.